Welcome to Math Cafe. Enjoy math sip by sip. In this video, we are going to see Introduction to Trigonometry. What is trigonometry? Why do we learn trigonometry? Where we are going to use this? These must be your questions. Have you thought about traveling from one place to another place? If you are traveling along the road, you know that there are traffic signs, signboards, and that will help you to travel in a safe way. And suppose you're traveling by air, and how a pilot decides the direction from where to where, how it goes, is simply moving on. What technology work behind that? Or if you are sailing in a ship, or you are going through a submarine, any sort of transportation, basically your GPS, all are working based on trigonometry. And if you noticed, you can see always some angles, 0, 30 degrees, or 031.12, like that, some angles. For every transportation part or moving one place to another place, you need trigonometry and the coordinate geometry combined. Using this, make the direction or to finalize the direction. So trigonometry is one of the most important topic in our day-to-day life, and in particular in math, and you need to learn with a proper understanding and meaning. We'll come back to our original question. What is trigonometry means? Trigonometry means Hipparchus is considered as father of trigonometry, and from where this trigonometry started. Basically, this is trigon and metry. What is trigon? Trigon means it is a three-sided figure, and you know clearly it is a triangle. And metry means measurement. You need to measure. For a triangle, as you are aware, there are three sides and three angles are there. 6 parts are for a triangle. Trigonometry helps you to find missing value. Suppose if you are given 2 sides, then you can find the third side, or one angle is given, you can find other angle. All these problems can be dealt with the trigonometry. Unfortunately, such questions are not seen in this class in the 10th standard. You will be seeing such applications in the later stages. And you must be heard trigonometry used to measure the heights and distance, and then height of a tower or a height of a building, or distance of the board, how much distance from you where you are standing. Applications you must be heard, and these are other applications. Trigonometry, if you take a triangle, is it necessary that triangle should be always a right triangle, or trigonometry is applicable only for right triangle? These are the common confusions. Trigonometry is applicable for any sort of triangle, irrespective of right triangle or non-right triangle. If you have a triangle like this, here also we can apply trigonometry. How do we apply? Simple thing, if you drop a perpendicular from one of the vertex to the opposite side, the triangle divides into 2, and each one of them will be a right triangle, and you can easily apply the idea of trigonometry. Basically, we will be allowed to consider a right triangle in the beginning, then slowly we'll change it to that. And let us consider this particular right triangle ABC. Clearly, angle B is 90 degrees. As you know that the side opposite to right angle is the longest side. The side opposite to the right angle is the longest side, and we call it as hypotenuse. Now we are going for some reference application or reference terms. We say I'm taking angle C. With respect to angle C, which is my opposite side. So AB is the opposite side, and for BC will be what? Near to C, so it is an adjacent side. This adjacent side and opposite side keep changing, depends upon the angle whichever you are referring. Say if I take angle A, suppose I am taking angle A. Now which is the opposite side? Which is the opposite side? The side exactly opposite to that, that means this one. So this is opposite side. And then if you consider the adjacent side will be A. So adjacent side and opposite sides are depends upon the angle. If the side is opposite to A, usually if you have a triangle ABC, and if you are considering the opposite of angle A, the left out letters will give you always the opposite side, that is BC. And if you are taking the adjacent side, it is AB. We are going to consider the most important part of the trigonometry, that the trigonometric ratios of a given angle. For this particular angle, suppose I'm considering some ratios of particular to that angle C. That means what will be the value of opposite side of angle C divided by the hypotenuse, that is AB by AC. Similarly, the adjacent side by hypotenuse and opposite side by adjacent side. What will happen to these ratios for a given angle? That's what we are going to see. For any given triangle, what will be the value of the ratio of opposite side to the hypotenuse and adjacent side to the hypotenuse and opposite side to the adjacent side? These ratios have any special property, or what will happen if the length of the side keep changing with a fixed angle? So the angle I'm keep fixing and I'm keep changing the sides lengths. Let us see the triangle. Here I have taken the same triangle ABC. This angle I'm considering this one, angle A. With respect to this angle A, the opposite side I marked, and adjacent side I have already marked the length of the opposite side, adjacent side and hypotenuse for your convenience. Now let us see opposite by hypotenuse, the first ratio. Keep looking at this value, opposite side by hypotenuse. See, I'm keep changing the side length. See, it's always remain what? The same. So whatever be the size of the triangle, the ratio of opposite side to the hypotenuse keep remain always the same, and it is 0.5. And similarly, if you observe, see the 0.866, that the ratio of the adjacent side and hypotenuse, that also always the same. Similarly, the opposite side by adjacent side, ratio of opposite side by adjacent side, that is 0.577, that also keep as a constant whatever be the side of the triangle. See, I have kept a fixed angle 30 degree, and if I keep changing the sides, the lengths, the ratio remain the same. Now you may be thinking that it will work for only 30 degree. It is not for 30 degree. Any acute angle it will work. I am keep changing to another angle 44 degree. So now the ratio is what? Opposite side by adjacent side is 0.695. Now let us see again what will happen to the ratio. See, all the three ratios are remain the same irrespective of if we change the side lengths. This is what one of the most important property of trigonometry. The ratio of opposite by hypotenuse is always a constant for a given angle. Similarly, the adjacent side by hypotenuse for a given angle, it's always same, and opposite side by adjacent side is also a constant. Whatever be the angle you take, the value always it will be true, whether it is 30 or 24, any degree, these conditions are always true, and this is one of the most fundamental property of math. This is what we have seen already. For any given right triangle, the ratio of opposite side by hypotenuse, and this ratio we'll call it as a special name, and this is called sin A. So this sin A usually we'll write as sin-A. This sin A means sine of the angle A. Please don't misunderstand that this as sine times A. It's totally absurd. Never think like that way. So this is always sine of the angle A. Sine of the angle A means opposite side by hypotenuse. And for the other ratio, that is adjacent side by hypotenuse, we have another name, that is actually cosine A, and we written as cos A as an abbreviation. So cosine A or cos A. And the third one, the ratio of opposite side by adjacent side, this is actually tangent A, and it is taken as tan A. Sin A, cos A and tan A. So sin A means it is a ratio of opposite side with hypotenuse, and cos A, the cosine A, means it is adjacent side by hypotenuse, and the tangent A or tan A is opposite side by adjacent side. If you want to make it precise, we can say sin A equal to opposite side by hypotenuse, and cos A is adjacent side divided by hypotenuse, and tan A equal to opposite side by adjacent side. You have to remember like this way: so, ka and to. So, ka, to. First three letters will give you sine. So this sine means opposite by hypotenuse, and cos means adjacent by hypotenuse, and tan means opposite by adjacent side. So SOHCAHTOA will give you all the ratios easily. Any right triangle, sine equal to opposite by hypotenuse, cos means adjacent side by hypotenuse, and tan means opposite side by adjacent side. They are reciprocals of each other. So this is what the relation. cosec A equal to 1 by sin A. Similarly, sin A will be equal to 1 by cosec A. And sec A is 1 by cos A, or cos A equal to 1 by sec A. And cot A equal to 1 by tan A. Cot, tan, cos, sec have some relation with the pronunciation part, whereas cosec and sin there has no relation. Cosec and sin. So these are the first or the basic 6 trigonometric ratios whenever you are given a particular value and you need to find the other one. I repeat some fundamentals not to make confused. This sin A or sin theta or sin x, anything will be possible with an angle. Sine of this actually means sine of an angle, or in general trigonometric ratio of an angle. Never consider that the sin x means sine into x, or never write the trigonometric ratios without an angle. And if you just imagine the sin x without x, I think you all know the word meaning sin. This is clearly a sin. It is a mathematical sin, writing trigonometric ratios without any angle. Please keep in mind that's a common error people do. No trigonometric ratio will exist without an angle. And you have remember what I have shown in the beginning. You are always finding sine of an angle or cosine of an angle or tan of an angle. Never write trigonometric ratio without an angle. That's purely a mathematical sin. Let us see some examples. This is the general format of the first type of question from this section. You will be given one of the trigonometric ratios and you need to find all the remaining trigonometric ratios. Hope you remember we have 6 trigonometric ratios: sine, cos, tan, sec, cosec, cot for the given angle. Let us see first what is a right angle. So here given B equal to 90 degree. So mark angle B first. Now with respect to our question, this is tan A. A is the given angle. Now with respect to A, which is the opposite side and adjacent side and hypotenuse. Hypotenuse we already know. And with respect to A, this is our opposite side and this is what adjacent side. Now we are given that tan A equal to 4 by 3. Can I say the opposite side is 4 and adjacent side is 3? Because tan A equal to what? Opposite side by adjacent. As we know that our SOHCAHTOA. So TOA. So TOA. Can I say opposite side is 4 and adjacent side is 3? If you say yes, you are absolutely wrong. You cannot say it is opposite side is 4 and adjacent side is 3. Why? It is clearly a ratio. So it could be 4 by 3 or 40 by 30 or 400 by 300 or any multiples will be possible. That is why here we will not say O equal to 4 or opposite side is equal to 4. Instead of that, we will say this opposite side will be some multiple of 4. So you write always 4k and adjacent side as 3k. Now to get the other trigonometric ratios, definitely we are in need of the hypotenuse. How do we calculate hypotenuse? We know the Pythagoras theorem. In right triangle ABC, AC square is equal to AB square plus BC square, and that is AB is 3k the whole square plus BC 4k the whole square. This is 9k square plus 16k square, that is equal to 25k square. Therefore AC equal to 5k, as I am going for the length of AC. Now we'll consider each trigonometric ratio. Say sin A. If you recall our SOHCAHTOA. So means opposite by hypotenuse. So sin means opposite by hypotenuse. Opposite side is here 4k and hypotenuse we have already calculated as 5k. 4k by 5k, this is equal to 4 by 5. Immediately you can write what? The reciprocal, that is cosec A equal to 5 by 4. You have evaluated two ratios, sin A and cosec A. Let us consider the next ratio, cos A. Cos A is adjacent side by hypotenuse. For adjacent side we have 3k and hypotenuse is 5k. So this is equal to 3 by 5. Therefore its reciprocal cos, so it is sec. Sec A is 5 by 3. Now tan already given. So therefore cot A equal to the reciprocal of 4 by 3, that is equal to 3 by 4. This is the first type question and the easiest one and simple. Let us see the next question. In a right triangle ABC, right angle at B, if tan A equal to 1, then we need to verify that two sin A cos A equal to 1. Here you need to find only sin A and cos A, and then we need to verify this condition is true. Here we are given that tan A equal to 1. Tan A, SOHCAHTOA, tan means opposite by adjacent side. Tan A equal to 1, 1 means 1 by 1 we can say. The opposite side of angle A must be 1 unit or multiple of 1 something, so we can say this is a K, and adjacent side is also 1, that we will consider it as another K. As it is 1 and 1, it could be 1, 10, 10, 100, 100, 20, 20, anything. That's why we use always a multiple of that particular given number. Now in right triangle ABC, again AC square is equal to AB square plus BC square. K square plus K square, that is equal to 2K square. Therefore AC will be equal to root of 2K square, that is equal to K root 2. Here we are in need of sin A and cos A. So we know that sin A equal to opposite by hypotenuse, that is K by root 2K, that's equal to 1 by root 2, and cos A equal to what? Adjacent side by hypotenuse, that's a Ka, SOHCAHTOA. So this is again K divided by root 2K, 1 by root 2. Now we'll go for the last part. We need to prove 2 sin A cos A equal to 1. LHS, that is equal to 2 sin A cos A is equal to 2 times. We have already seen sin A is 1 by root 2 and cos A also 1 by root 2. So 2 divided by root 2 times root 2, that is another 2 is 1. Let us see another example. In triangle PQR, angle Q is equal to 90 degree, PR plus QR equal 25 centimeter and PQ equal 5 centimeter. Find the value of sin P, cos P and tan P. Angle Q is 90 degree, that we have already mentioned, and PQ equal to 5 centimeters, that also given. We are given PR plus QR equal to 25 centimeters. They didn't mention exactly what is PR and QR. Instead of that, given combined value is equal to 25 centimeters. But you need exactly what is PR and QR, because we are supposed to get the angle related with the P, opposite side of this, and adjacent side, and the hypotenuse. We need all three to complete the question. From here I can say PR equal to 25 minus QR. Now just like the other questions, we will proceed. In right triangle PQR, PR square equal to PQ square plus QR square. PR is, we have taken as 25 minus QR, the whole square, and PQ is, we have already known, 5 square and QR square. I am opening this with identity A minus B the whole square, A square minus 2AB plus B square, 25 square minus 2 into 25 into QR plus QR square equal to 25 plus QR square. You can see both the sides QR square is there, can cancel them, they are equal to each other. Now this is 625 minus 50 QR equal to 25. I'm taking 25 to this side, 25 on the left side, and 50 QR go to the right side. So 600 is equal to 50 QR, or QR equal to 600 divided by 50, cancel that, 60 by 5, that's equal to 12. And as PR plus QR is equal to 25, QR is equal to 12, and PR will be what? 13 centimeters. This is 13 centimeters and QR is equal to what? 12 centimeters. This is a normal way of doing with like a descriptive answers. But in case if it is an MCQ, never try to do all these things. Just check one of the side is 5 and the sum of the other two sides is 25. So you know that the Pythagorean triplets 12, 5 and 13. Immediately write 12, 13. Please keep in mind, whenever you attempt an MCQ question, never try to write all the steps and waste your time. Use your smart thinking and do the work in a smarter way and get the answer directly. Now we need to calculate the value of sin P, cos P and tan P. We have got all the three sides. Now we'll use our SOHCAHTOA to get the corresponding ratios. Let us calculate sin P, cos P and tan P. Sin P is equal to opposite side by hypotenuse, and opposite side here 12 divided by 30. And then cos P, again adjacent side by hypotenuse, SOHCAHTOA, adjacent side by hypotenuse, 5 divided by 30. And tan P equal to opposite side by adjacent side, that is equal to 12 divided by 5. We have done all the three parts which is required for the question. and we have completed that. Let us see one more similar question related to the previous one. Right angled at P, OP equal to 7 centimeters, OQ minus PQ equal to 1 centimeter. Just like other one, OQ minus PQ equal to 1 centimeter. As OQ is the hypotenuse, we can say it is 1 plus PQ. In right triangle OPQ, you know that OQ square is equal to PQ square plus OP square. OQ, we made it as 1 plus PQ, 1 plus PQ, the whole square equal to PQ square plus OP square. And OP is 7, so we substitute the value 7. A square plus 2AB plus B square. That is 1 square plus 2PQ plus PQ square equal to PQ square plus 49. PQ squares get cancelled. 2PQ equal to 49 minus 1, that is equal to 48. Therefore, PQ equal to 48 by 2, that's equal to 24. Now PQ equal to 24, therefore from 1 you can write what? OQ will be equal to PQ plus 1, that is equal to 25 centimeters. Hypotenuse is 25 centimeters and QP equal to 24 centimeters. And we need to find the value of now sin Q and cos Q. Let us calculate sin Q and cos Q as per the question now. Sin Q is the angle is Q, sin Q the opposite by hypotenuse. Opposite is 7 centimeters and hypotenuse 25, so 7 by 25. And cos Q equal to adjacent by hypotenuse, that is 24 divided by 25. They asked only for sin and cos, so we are stopping that, sin Q and cos Q. Other values are not required, so our answer is complete here. Thank you for watching Math Cafe. If you enjoy the video, please like, subscribe and share. We will see you again with the next topic of Introduction to Trigonometry. Thank you.